Hi, I'm RC Jim. This is now the second in our series of videos on fail-safe management for RC planes. We had the first one where we talked about what failure modes are, just various ways of what could go wrong. And we had a look at mechanical, structural things. This particular one, we begin to look at the electronic things that could go wrong. We'll get into that in just a moment, but I just want to let you know that all of this is available in a document that I've written up to utilize as training material in your club or wherever you might be. It's available for free on our website. So have a look at rcgym.com, rcgym.com, and you will find a lot of helpful things like this that support our videos. So thank you for watching, and I trust that this will be helpful for you. So stay tuned. Well, next we get into our electronic gear. Well, as you think about these things and all that's involved, what could go wrong? Well, I'll tell you, as you think about this, we got a whole bunch of stuff happening. You've got a transmitter, and that's sending a signal through the air to a receiver that has a couple of antennas on it. Hopefully those antennas are going to pick up the signal. But in order for it to do anything, it has to have power. So power is going to come from a battery elimination circuit on the ESC, the electronic speed control. So that's going to give us some power there. Either that or you might have a separate power supply. But for the ESC to be able to give power to the transmitter, it's got to get power from the battery. And so you got that down here. And then, of course, the ESC is not only going to give power to the motor out here, but it's also going to tell it how fast to go and, regulate things, that nice little rotating magnetic field sort of thing that's happening in there. And then the receiver, it's got to do more than control the motor. It's also got to control the servos that are hooked to our control surfaces. And sometimes we may have a Y connector, Y harness in there connecting a couple of ailerons or something like that. And sometimes we might have to have extensions to get farther out to them, all that type of thing. So what could possibly go wrong? Well, as you think about it, you could have a connection failure with one of these things. Might be corrosion in the connectors. There's a connector each place where it goes into the receiver. Anytime you've got either an extension or a Y harness, there's extension or the connectors on both sides of those things there. And one of those connections might fail. It might get pulled apart. It might have corrosion in there. Of course, getting pulled apart, that might be through handling and just sort of, putting in the battery, you accidentally yank on one of the wires or something like that. It could be vibration, could be things shifting around in the plane, various things like that. You can have connections that deteriorate. Now, I haven't experienced it myself. I suppose my history with the electric planes isn't long enough, perhaps, but especially high-powered connections where, I got a 100-amp ESC here, and I put a great big battery on that with whopping amount of current going through there, the actual connector can deteriorate over time. So lots of things can happen. So you need to be making sure that you make regular visual inspection of things. Think about the deterioration of the connector. Look inside there, see if it's bright and shiny and gold, And if it's looking all tarnished and whatever, get rid of it. It doesn't hurt to wiggle things at times when you're working stuff. Look for any sort of heat damage. In this particular case, another kind of damage. I don't know if you can see that or not, but yeah, it got poked into with a crash someplace along the way, which is why this is not in a plane right now. Yeah, visual inspection will help a lot. Also, when you finish flying, it doesn't hurt to every once in a while, just check to see how hot things are. Be careful, because you don't want to go burning yourself if the thing has gotten super hot, but a bit of a tap on it and see what's happening. So the motor, the ESC, the battery, all of those things you ought to be checking about heat and all to make sure that everything is okay. If something looks dodgy, consider it dodgy and replace it. Okay, it's much safer to be that way. Okay, so you think about heat damage to the motor, the ESC, the cables, and things such as that. That certainly is something that can also cause a plane to quit. I had well, I still have a P-51 that cooked the ESC in it. And with that one, I had some nice flights and everything is going fine. I'm just whipping around and I'm getting ready to get lined up to take off again. And I jam the throttle forward a bit, and the thing, being a tail dragger and a bit nose heavy, noses into the ground. And apparently I didn't pull up back the throttle quick enough because it wouldn't work after that, and got it out and had a look, and the ESC was fried. Now that particular one, I was kind of guilty on two counts. One is that I had noticed that ESC had previous heat damage to it. You could see that it was melted a bit on the covering, and so it had a problem in the past. It was a plane that I acquired from somebody else, and somebody else had something similar happen to it. And then I inquired with the club members, and one of them pointed out to me that particular brand of ESC comes standard from the factory with a helicopter type programming in it, where the throttle is controlling the RPM. With a helicopter, you want to set the throttle to get a certain amount of RPM, and then as you put in the collective and the thing takes off, you want it to add power to maintain that RPM. Not so with an airplane. With an airplane, you put that prop into the ground. If it's trying to maintain the kind of RPM that the throttle stick is indicating, it's just going to draw an incredible amount of current and blow itself sky high. Something's going to go because it doesn't want to quit, and it just keeps on drawing more and more current to do what it's been told to do. So you want to have a non-helicopter setting on the ESC, one that just simply puts a certain amount of power to the engine, and whatever RPM that is, that's fine. So things like that can happen. And naturally, we're talking about things of concern here. As I have my batteries, I keep them when I'm transporting them, and when I've got them here in the garage, I keep them in a fireproof or fire-resistant at least container. And I do that because the things are volatile. They're made out of lithium. Lithium is highly flammable. The stuff gets too hot and it burns, it explodes, all kinds of things can happen with it. And you got one of these things powering that plane, and you run excessive current through it, and you're going to have a problem. And by the way, don't necessarily believe the C rating on the battery. 100 C, 100 times the C rating of the battery is supposedly what this thing is capable of taking. So that's saying 400 amps for this battery. Nah. I don't think this thing is going to live very long if it runs 400 amps through it. 100 amps, yeah, but not 400. So anyway, you need to give attention to what's going on with regard to heat, because it can really cause a problem if you're not careful. One other thing, just with regard to those batteries, is you can have a situation where with increasing heat, it's drawing more current, and this is especially true with charging. Heat goes up, it's drawing more current, causes the heat to go up farther, and it goes into a runaway condition that ends up in the battery destroying itself. So you need to watch out for that type of thing. Okay, so in terms of other things to be careful of with regard to the battery and the electronics in the airplane, make sure that you have properly sized the components. Have a look at some of our videos on electric motor testing in RC airplanes, and we go through to show you how to set up a test rig, and you can test thrust and you can test the current draw. But as a minimum, put a watt meter on it and run it up to full throttle and see what it draws, okay? And that will tell you what you need to be doing with that plane. My little F-16, sorry, my little F-16 FMS, that thing just draws way, way, way more current than what it's designed to take. And it's that way from the factory, okay? Now, I appreciate having the ability to put that kind of power to it because the thing doesn't have a rudder, and the only way to get it off the ground is to hammer the throttle, get it off really quick before you need to steer, and get it into the air so you can then steer it with the ailerons, you know. But nonetheless, because I know it's drawing so much current, I don't give it more than a couple of seconds at that full throttle. You know, that's it, and then I'm backing right off. And if I didn't know that, I might be tempted to impress everybody with its speed and, you know, do some high-speed passes and whatever. And next thing, have a flaming F-16 headed for the bush, and then I'll get the CFA, the Country Fire Authority, on my case for having started their most recent bushfire. So, yeah, be careful about such things and be aware of what's going on. You certainly need to make sure that your plane has got adequate ventilation for air to get through the motor, air to get into the compartment where the battery is and the ESC are, and a place for the air to get out. All of that's important to keep things reasonably cool and all of that. Okay, thinking about the potential damage to the ESC, where you've got an ESC like this that has the battery elimination circuit built into it, there is the danger that as this thing fries itself, it may also fry the chip or the circuitry that's involved in regulating the voltage for this battery elimination circuit. So one way to avoid that is to get an ESC that has the UBEC separate. So it's something that just simply provides the actual current from the battery. So this would come in here to a couple of lugs, and right connected to that would be the leads that go to the battery. So very little for going wrong there. And then with a UBEC, the little voltage regulator for the receiver, with the UBEC physically separate from the ESC, it's less likely that that's going to be damaged and more likely that you're going to continue to have power to the receiver. A step even better, and especially for large planes where weight is not an issue, is carry a separate 2S battery to power the receiver. Have a totally separate system, and of course you get real big planes and real expensive ones, they'll have two receivers with two batteries and, you know, redundant systems and things like that, because the thing is too valuable to lose. Okay, so those are things that you can do with regard to protecting against heat damage to your ESC. Naturally, if your battery is swelling, if it's showing sign of damage, get rid of it. You know, it's not worth losing your plane for the sake of getting another 10 flights out of your battery. Okay, another failure mode, low receiver voltage, causing the motor to stop and potentially loss of control. So naturally, the battery in the plane, it's going to be going down in voltage as it gets its charge used up along the way. We will typically be targeting, you know, 40-50% or whatever capacity when we finish, so that we've got plenty of capacity there. But I do know some guys that fly until the ESC slows the plane down and they figure, okay, I guess I need to land, you know. But, you know, maybe you lose track of time, or you're not looking at your transmitter to see what the time is, or you don't hear it. Maybe you're doing a lot of high power type stunts and things like that that's drawing the battery down a lot quicker than normal, so the time is actually, the available time is actually less than the planned time. But for whatever reason, the voltage has gone down, and with that, there's a variety of things that can happen. Most of the time with your ESC, you're going to have it programmed to either cut the throttle or reduce power to the motor. if the battery voltage gets down to a certain point. And of course that's to protect you. It allows enough power to be left in there to control the servos and things like that, so you can do either dead stick landing or low power landing. The reduced power mode, which is, you know, kind of the ideal one, it's obvious enough that you should be able to see or perceive what's going on and make a quick landing and everything be okay. But nonetheless, that is a potential problem. If you've got it set on the one that just simply cuts the throttle, then you're up there and all of a sudden the battery voltage gets low and the throttle is totally cut. And if the wind is blowing the wrong direction and you're in the wrong place, you might have a hard time getting back to do that dead stick landing. So that is certainly a concern. So you got a temporary voltage reduction. You could have an ongoing voltage reduction, and with a temporary one, anytime you have a high current draw on a battery, the voltage is going to go down. But as soon as the current goes back to a lower level, then the voltage will come back up on the battery. Now, what I didn't mention before, you know, the ESC has got some protections in it, but you can also program into the receiver, or some receivers, you can program in a fail-safe battery protection. And with that, if the battery gets below a certain level, then it goes into a fail-safe mode where it'll either shut down things or change them or, you know, do different stuff like that. And that will happen whether it's a temporary reduction in voltage or an ongoing one. And if it goes into the temporary one and switches everything off or puts controls all in set positions that won't change, unless you know what's going on or you've got the reset switch or the throttle, whichever is being used to reset it, unless you reset it, that plane is going to basically crash, you know. It might crash on the field and not go a long distance, but it's going to come down. So that temporary one is something you need to manage. And in a video following this, I'll be talking about the fail-safe settings that you can do for receivers, how you set them, what it means, how it works, and all of that. And that is an important one to really understand. Okay, so that temporary voltage reduction, the receiver can do some problems and have some problems that you need to cope with. The ongoing one is one that even if you reset it, it's still no good. And so with that, you're depending upon the ESC, and you need to make sure that you've done the programming on that properly. And again, we've got videos on a great variety of different ESCs. There's a different video for each of several different brands. And so have a look at that. You can program it either using the throttle stick on your transmitter, or you can get a program card, which is the easiest way to do it. That program card, typically you'll need to get one for each brand of ESC and maybe even a certain range of models of that brand of ESC. But they're quite cheap and they're really easy to use. So make sure you program the ESC properly. Well, again, I think we've given you enough content to begin digesting. This, of course, was the second in our series of videos on fail-safe management for RC planes. The third one follows. In that one, we finish up the matter of the electronic failure modes, looking at the loss of signal to the plane, what can cause that and how you can avoid that, and that type of thing. And then we will get into aerodynamic things that can go wrong, and also pilot type things, personal, you know, where, yeah, you or me makes a mistake and causes something terrible to happen. Yeah, that can be avoided as well. So all of those we'll be having a look at in the next video. Thank you for watching. You have a great day and happy flying.